Hey, you there. Are you struggling with binomials raised to the fourth power? Don't you just hate simplifying binomials raised to a fourth power? It's so tedious, and it's not as cool as simplifying squared binomials or cubed binomials. Well, fear not. Here at Oversimplified Mathematics LLC, we've come up with a solution to your problem. Introducing the quartic binomial identity. What's cooler than raising one binomial to the fourth power? Raising a trinomial to the second power. You might be wondering, how can we prove this identity? I'm glad you asked. We can prove this identity by using algebraic proof. We can prove that x plus y raised to the fourth power is equivalent to a trinomial squared. We can rewrite the right side of the equation as the same trinomial being multiplied by itself. We can simplify the left side of the equation using the binomial theorem. X plus y raised to the fourth power becomes x to the fourth power plus 4x cubed y plus 6x squared times y squared plus 4x times y cubed plus y to the fourth power. Back to the right side of the equation. After we simplify the right side of the equation, we can, say it with me now, distribute. After distributing, we see that both sides of the equation are equal to each other. Hooray! We've proved our identity algebraically. What's that? What do you mean you need further proof? I've got just the solution. We can prove it again by using, say it with me now, numerical relationships. Let's take two integers, 4 and 9. Suppose x is equal to 4 and y is equal to 9. If we substitute these values into both sides of the equation and simplify, we see that both sides are equal to each other. Hooray! Our identity has been proven yet again. Wait, what's that? Does this identity only apply to perfect squares? What if you choose numbers that aren't a perfect square? Excellent question. Suppose x is equal to 5 and y is equal to 11. If we substitute these values into both sides of the equation and simplify, we see that, yet again, both sides are equal. What's that? What about decimals? Good question. Suppose x is equal to 4/10 and y is equal to 7/10. If we substitute these values into both sides of the equation and simplify, this shows yet again that both sides are equal to each other. What about negative numbers? Suppose x is equal to -5 and y is equal to -6. You probably get the trick by now. If we substitute both sides of the equation with these values, simplify, you'll find that both sides are, again, equal to each other. The quartic binomial identity works with positive and negative integers, decimals, perfect squares and cubes, and more. Our statistics department took the time to create a graph showing the relationship between people who have used the quartic binomial identity and their subsequent happiness level. Those who have used the quartic binomial identity are reported to be 100% happier. Those who haven't used our identity showed no signs of enjoyment or happiness when solving binomials raised to the fourth power. According to those who haven't used our identity, quote, I've never wanted to not do binomials raised to the fourth power ever in my life. Another individual states, this is horrible. Please let me do anything else. I don't want to do this anymore. Another individual states, never before has something so simple yet complicated invigorated my hatred towards mathematics any more than this problem. Our last interviewed individual states, I never did finish high school math. All of this is Greek to me. As you can see, our math identity helps with solving binomials raised to the fourth power in a simple and effective manner. The future of solving quartic binomials rests in Oversimplified Mathematics LLC. Are you in?